And welcome back. We are going to continue our discussion about linked lists. Today we're going to particularly look at a slightly different variation, which is the doubly linked list. So when we look at a doubly linked list, you'll see that the structure is kind of similar to what we already know with a linked list. Now, an ordinary linked list allows us to move down the list in one direction only. We're following the link. So you start at the head node and move your way down. A doubly linked list, though, has one link that has a reference to the next node and one that has a reference to the previous node. If you look at the diagram here, you see, of course, we have the single link coming down, but then there's also a reference coming back up. In some cases, the link to the previous node can actually simplify our code. For example, we no longer need to have a previous instance variable to remember the node that links to the current position. So it's, again, a way to kind of simplify our code and make it a little bit cleaner. So how do we actually go about creating that doubly linked list? Well, the node class for a doubly linked list can begin as follows. Private class, two-way node, private string item, private two-way node previous, private two-way node next. Of course, again, next and previous because we need to keep track of those two positions. Now, the constructors and some of the methods in the doubly linked list class will require some changes from our single linked list case in order to us to accommodate this actual link that we're having to do. And this is why it's a doubly linked list, because we're having two links. We have the previous and we have the next. Now, when we talk specifically about those method changes here, one of the major changes that we're going to have to look at is the add and delete of the nodes, because obviously we're having to accommodate more links. So to make our code a little cleaner, we can add a new constructor that says the previous and the next nodes. Public two-way node, string new item, two-way node previous node, two-way node next node. Item is equal to new item, next is equals next node, and previous is equal to the previous node. So when we start looking at adding these nodes into our list here, if we want to add a new two-way node to the front list, well, this is going to require setting links on the two nodes instead of one, because obviously we're having, again, more links to manage. Now, the general process is shown here. So if we look, we have an existing list in this example. And we can see we have our two links that we're pointing. So we're pointing to the next node and a reference back to the previous. And let's just say we want to create a new node. So we're going to go ahead and insert that in here. And then, of course, we have a backward link to set the head. And so let's actually look at how this process is working, besides just looking at a couple code snippets. So we want to actually start getting to navigating this list. So in that add to start method, the first thing we do is we create a new two-way node. Because the new node will go to the front of the list, we're going to set the previous link to null and the link to the current head. So we want, of course, because the head, the next link is going to be the current head because we're trying to move that reference along. So the way we do this is by two-way node, new head equals new two-way node, item name, null head. Next, we set the previous link on the old head node to reference the new head. We can do this by setting head.previous is equal to new head, but we do need to take care to ensure that head is not null, or in other words, it's saying that the list is empty. Then, of course, we can just set head to the new head. So if the head is not null, we're going to say head.previous is equal to new head, head equals new head. Now, what about deleting a node? Now, you'll see that with deleting a node, we have, again, a very similar pass that we would have before. But if we're doing this with a doubly linked list, this, remember, requires updating the references on both sides of the node to delete. Now, thanks to our backwards link, there is no need for an instance variable to keep track of the previous node list, as we had to do when we had a singly linked list. Because, again, we have already a thing set up to handle it. We have a previous link. Now, the general process of deleting a node is referenced by the position shown at right. Now, in some cases, this has to be handled separately, such as deleting a node from the beginning or the end of a list. But if let's just say we're pulling from the middle of a list, it's pretty simple. We, of course, can have our existing list. We're going to remove an item from that list by bypassing it. Effectively, the same thing as what we did before. And updating all of our pointers here, all of our different references of these nodes. And then of course, Java's garbage collector will come along, see that this is not referencing anything, it'll remove it and clean up the list. All right, if we look at our doubly linked list example, one of the things you will notice is this again is a structure that's very similar to what we've seen before with our single linked list. And so let's actually look at this with a demo, because that's going to help give us a better understanding. And so if we look here, it's again very similar to how we operate our singly linked list. Of course, we're just going to add to the start of that list, because remember, it's going to put it at the header. And then it's going to, of course, print out that list. And then what we want to do is, of course, look at some different things. So, for example, we're going to delete an item out of that list, and then we're going to get what is inside the list, and then we're going to insert an item into that list. So, if we go ahead and run this code, all right, first thing to do, we get list contains coat, orange juice, and shoes. Remember, because it's always adding at the head of the list. So even though shoes is the first item here to be added, it is not the last item in the list, because you know it's here at the bottom. Then, of course, if you look down here, we have the option to delete out shoes. So we're deleting out shoes because it's peeking. It's saying, hey, what is the last item here? So we're taking shoes out. And so then we're going to then reprint that list. So now we have coat and orange juice. And then we want to insert the term socks. And so it's looking at with the peek again here. And you'll notice it's now going where it says list now contains coat, socks, and orange juice. And notice where it inserted was right here in the middle between these two. So that is a quick overview and look at the doubly linked list. Again, it's very similar to what we've seen with a single linked list. But there are some advantages to using the doubly linked list over a singly linked list.